Hello! In this demonstration we will be showing the EDHOC protocol for establishing an OSCORE security context. And OSCORE is a protocol for end-to-end security. So what we will be doing is, on the left hand side here, I have a client running on this local laptop, and on the right hand side I have the server, which is on the Raspberry Pi that you can see in the bottom right corner. So the Raspberry Pi is attached to a LED light, and we will be triggering this LED light with requests coming from the client. So what we want to accomplish with this demo is showing the EDHOC protocol in various configurations, both using signatures and MACs, and also showing a vanilla workflow and comparing that to our optimized workflow. And the point of running EDHOC here is that by running EDHOC, we establish an OSCORE context with the server, and when we have that OSCORE context, we can run OSCORE and achieve end-to-end security for the communication. So what I will be starting off with is showing basically on the right hand here on the server an OSCORE server, and on the left hand side I will then start a co-op only client. So what will happen in the case of a co-op only client sending a request to an OSCORE server? So you see here, press enter to send co-op message, and I can press enter now to proceed with that. It will try to turn on the LED, but since this is not using OSCORE, you simply get an unauthorized error message from the server. So that was just the phase 0, let's say, initial phase. But now we actually move into using EDHOC. So what I will do here is, on the server side, I will start a phase 1 server, which is an EDHOC enabled OSCORE server. So it's ready to run EDHOC with the client, and after that receive OSCORE requests. So the server is running. I will also start the client here on the left hand side. And what you can see here now is that this is in fact client 1 with the vanilla workflow. And the vanilla workflow is basically that you first run EDHOC, meaning you have EDHOC message 3 as a request from client to server. Then you have EDHOC message 2 as a response message from the server. And then you have EDHOC message 3, which is a request from the client to the server. And then there's also an acknowledgement for message 3. And only after you finish that EDHOC execution can you start the OSCORE communication. And this case is using EDHOC where you authenticate with signatures. So let's see what happens now if I hit enter to send a request to the server to try to turn on the LED. And I will also start here a capture in Wireshark so we can actually investigate what's happening, what data is being exchanged. So I press enter now to start the client. And as you can see in the bottom right, the LED has turned on. So the client and server successfully ran EDHOC, and after that the client sent an OSCORE request to turn on the light. So now I will actually send the 0 command here to turn off the light, and I will quit the client and I will quit the server. And now we can take a look at some of the output. So we have a text file here we're writing to continuously when we run the client, and well, this is output for client 1 with the vanilla workflow. And basically you can see the core payload and UDP payload of the different messages that were exchanged. And this will become more interesting as we see the other cases basically. One thing to note though, if I look at Wireshark, is that you can actually see here you have these messages. You have 1, 2, 3, 4, 5, 6, meaning 3 round trips to actually get the OSCORE response back. So you have EDHOC message 1, 2, 3, the ACK for message 3, the OSCORE request, and the OSCORE response. So 3 round trips before you get a confirmation that the LED has turned on. So this is something to note for the future scenarios. So then as a next step, I will show a different configuration on the server, which is the phase 2 configuration. So I start the server, and I will also start the phase 2 client. So what is different here is, well, you can see here, well, still the vanilla workflow, but this time we have authentication with MACs, and you will see how that is different. Well, I press enter to now start the client, run EDHOC and send OSCORE request. And again, as expected, the LED turns on. I will send the zero command to turn off the LED, and then I will quit the client, and I also quit the server. So now if we have a look at the file again, and I reload it, well, what we can see here is that we have the lines for client 2, and something to note here is that for EDHOC message 1 we have 69 bytes of UDP payload and 38 of COA payload, which is exactly the same as the signature mode. But if you look at the EDHOC message 2 and 3, you can see that the payloads here are significantly smaller compared to the signature modes. And this is because really the Macs have a lower overhead than using signatures. And then if I have a look at Wireshark, well, again, you have 1, 2, 3, 4, 5, 6 different messages to finish the to get their actual OSCORE response. So that's 3 round trips. And if you're curious, these in between messages are for turning off the LED. Also listed for turning off the LED. So, well, still 3 round trips, but we have less overhead than the signature mode. So these were the vanilla workflows. And again, the vanilla workflow of EDHOC is that you have to run EDHOC message 1, 2, 3, and only then can you run and start the OSCORE communication. But what I will show next is an optimized workflow we have developed. So I start phase 3, which is one of the optimized servers, and I start the phase 3 client here. So what's the difference? Well, this is client 3, optimized workflow, and you have authentication with signatures. So authentication with signatures, that's the same as the phase 1 client 1. But the difference here is the optimized workflow. And what this difference actually means is that instead of first running EDHOC and only then starting OSCORE, you actually combine EDHOC message 3 with the OSCORE request into a single message. So this gives you an optimization compared to the vanilla workflow. So I will show you running this. And yeah, the LED turns on expected. I can switch off the LED, and I quit the client and I quit the server. But this is where it's a bit interesting to have a look now at the text output. So you have now the optimized workflow, which is authentication with signatures. And again, the payload is comparable for EDHOC message 1. But I think one thing to note here is that you actually have EDHOC message 1, EDHOC message 2, and instead of just EDHOC message 3, you actually have EDHOC message 3 combined with the first OSCORE request. And after that, you have the OSCORE response as expected. And now if we have a look in Wireshark, well, now we actually see we have 1, 2, 3, 4. So only 2 round trips to finish this whole procedure. You have EDHOC message 1, 2, then you have the combined EDHOC message 3 plus the OSCORE request, and then the OSCORE response. So what you can see here in the optimized workflow is we have 2 instead of 3 round trips. So we actually managed to shave 1 round trip off compared to the vanilla workflow. And I will also show one final configuration. That is, again, the optimized workflow in phase 4 server. And I launched the phase 4 client. So what's the difference here? Well, we have the optimized workflow, but now we have authentication with Macs. And I will execute the client. And again, the LED turns on expected. I will switch the LED off and quit the client and quit the server. So let's have a look at the text file and output. Well, what can we see? Well, this is the optimized workflow, authentication with Macs. And again, you see the EDHOC message 1, 2, and then the combined request here. And one thing to note here, you can have a look at the UDP payload here. I mean, if you compare here, this is again authentication with Macs for the vanilla workflow. If you have a look here, you see you have 92 bytes COA payload and 101 bytes co-op payload for incoming traffic, and that's really exactly the same as here, 92 and 101. But where it becomes interesting, if you look at the UDP payload, the total outgoing traffic for the vanilla workflow is 188 bytes, but the total outgoing traffic for the optimized workflow is only 158 bytes. And this is because we combine the EDHOC message 3 and OSCORE request 1. So we have less overhead in terms of co-op headers. And I also want to show then the Wireshark output. So let's have a look here. Well, we have 1, 2, 3, and 4. So again, only 2 round trips to finish the whole procedure compared to 3 in the vanilla workflow. And so this really concludes our demo, and thank you for watching.